On September 18, 2025, the Earth shuddered beneath the restless Pacific, just off the rugged coast of Russia's Kamchatka Peninsula. In a region already known for its volatile geology, the ground convulsed with a force that echoed across continents. A magnitude 7.8 earthquake jolted more than 240,000 people awake, toppling buildings and fracturing roads. This powerful tremor struck mere weeks after a massive 8.8 quake had already left the region on edge, amplifying fear and uncertainty among residents. Emergency crews rushed to assess the damage while families gathered in the streets, searching for loved ones and news of what might come next. As scientists scrambled to make sense of the seismic chaos, another team turned their gaze skyward. High above, a vast coronal hole had rotated into view on the sun's surface, releasing a torrent of charged particles, solar wind, directly toward Earth. The timing was impossible to ignore. This high-speed solar wind, traveling at over 1,000,000 miles per hour, was set to collide with our planet's magnetic shield within days. Scientists braced for geomagnetic storms, knowing these solar outbursts can disrupt satellites, power grids, and even the delicate balance of our atmosphere. The timing was uncanny. Could the sun's sudden activity be linked to the violent shaking of our world? Researchers debated, poring over data, searching for patterns that might reveal a hidden connection between solar storms and seismic unrest. While tsunami warnings blared across the region, no destructive waves followed this time. The alert systems worked as intended, sparing coastal communities from further devastation. Yet beneath the relief, a deeper mystery lingered, one that technology alone could not answer. Data streamed in from seismometers and solar observatories around the globe. Patterns began to emerge, subtle but impossible to dismiss. The interplay between Earth's crust and the sun's energy demanded closer scrutiny. Was this all a mere coincidence, or were we witnessing the first hints of a profound connection between the sun's fury and the trembling of our planet? The question echoed through labs and observatories worldwide. To unravel this enigma, we must journey from the ocean's shadowy depths, where tectonic plates grind and shift, to the blazing heart of our solar system. Only by exploring both realms can we hope to understand the forces that bind our world to the star that gives us life. Kamchatka is a land of extremes. Over 160 volcanoes, 29 still active, perched on the volatile edge of the Pacific Ring of Fire. This remote peninsula, stretching into the far eastern reaches of Russia, is one of the most geologically active places on Earth. Its landscape is a dramatic tapestry of snow-capped peaks, steaming vents, and rivers of lava shaped by millennia of eruptions and upheaval. Here, the immense Pacific Plate dives beneath the Okhotsk Plate at the Kural-Kamchatka Trench, a process known as subduction. This relentless collision of titanic forces deep beneath the surface drives not only the region's frequent volcanic eruptions, but also its powerful earthquakes and constant seismic activity. The July 2025 Megaquake was a stark reminder of these forces at work. In a matter of moments, the peninsula shifted by up to 2 meters, reshaping coastlines and altering the very contours of the land. It was a dramatic, visible display of the power of plate tectonics, and a testament to the ever-changing nature of Kamchatka. Kamchatka's violent history is written in the scars of the land. The devastating 1952 M7.8 earthquake and the tsunami that followed left entire communities in ruins, and their memory still shapes how cities and villages are built today. Modern buildings are designed to withstand the Earth's fury, a constant reminder of the risks that come with living here. These recent quakes are just the latest chapters in a story written in fault lines and volcanic rock. Every crack in the earth, every jagged ridge tells of ancient upheavals and ongoing turmoil beneath the surface. The region is primed for earthquakes. Tectonic stresses are immense and ever-present. Scientists monitor the land closely, using sensitive instruments to track every tremor, searching for patterns in the chaos. This closed system of terrestrial forces, locked in a perpetual struggle, explains the frequent shaking that rattles Kamchatka. The ground here is never truly still, yet, the suggestion of a solar influence, energy from the sun somehow affecting seismic activity, challenges this orthodox view. Could forces from beyond our planet play a role in the drama unfolding below? It pushes us to look beyond the ground beneath our feet, to consider the possibility that Kamchatka's story is shaped not just by the Earth, but by the cosmos itself. Now, let's turn our attention to the sun, a churning dynamic ball of plasma where immense magnetic fields are in constant, restless motion. The sun's surface is far from calm, it's a seething ocean of energy, with magnetic loops and arcs twisting and snapping, shaping the very nature of our solar system's space weather. Occasionally, these magnetic fields open up, creating what scientists call coronal holes, vast dark patches that appear in ultraviolet images. In these regions, the sun's magnetic field lines stretch far out into space, allowing charged particles to escape at incredible speeds, forming powerful streams of solar wind. When a coronal hole rotates to face Earth, a high-speed stream of solar wind is unleashed in our direction. These energetic particles travel across the void, reaching our planet in just 2 to 4 days, carrying with them the potential to stir up dramatic effects in our near-Earth environment. Earth's magnetic field acts as a protective shield, deflecting much of this solar wind. But when the impact is strong, it energizes our magnetosphere, sparking breathtaking auroras in polar skies and at times causing disruptions to satellites, navigation systems, and even radio communications. These intense solar wind streams can also induce electrical currents deep within the ground, sometimes overloading power grids and affecting the stability of our technological infrastructure. The effects can ripple through communication networks, navigation systems, and even airline operations. This ongoing interplay between the sun and Earth is what scientists call space weather, a complex, well-studied interaction that is constantly monitored by observatories and researchers around the world. But a key question remains: could these solar disturbances reach even deeper, somehow influencing the powerful tectonic forces that shape the ground beneath our feet? The possibility is tantalizing, hinting at a hidden connection between the cosmos and our planet's restless geology, yet the exact mechanism remains elusive, and the scientific community continues to search for answers. Still, the curious timing of some solar and seismic events keeps the debate alive, fueling speculation and ongoing research into whether a deeper link truly exists. Are we overlooking a hidden thread that ties the sun's storms to the quakes that shake our world? The search for answers continues. The idea that the sun could trigger earthquakes is controversial, largely due to the vast energy difference. Plate tectonics are driven by Earth's internal heat, far more powerful than any solar storm. Yet, some propose that solar activity might act as a trigger, nudging critically stressed faults over the edge. The mechanism? Perhaps electromagnetic currents induced during geomagnetic storms subtly alter fault friction. The Kamchatka quake's timing with a recurring coronal hole is compelling, if anecdotal. Correlation doesn't equal causation, but persistent patterns are hard to ignore. Our brains seek patterns, but science demands evidence. Still, when timing and theory align, even skeptics take notice. The debate splits the scientific community. Most seismologists insist earthquakes are purely terrestrial, driven by plate tectonics, no outside trigger needed. The USGS and others find no accepted evidence linking solar activity to seismic events. Their models explain stress buildup and fault mechanics with increasing precision. For them, solar wind is a negligible factor. Yet, a minority of researchers and a curious public point to statistical correlations between solar storms and earthquakes. They argue that electromagnetic effects, though small, could be significant in critically stressed zones. This tension between established science and new hypotheses is classic and necessary. Skepticism guards against false leads, but open-mindedness drives discovery. Should we stick to what we know, or explore the possibility of a deeper Earth-Sun connection? Experts remain divided. Seismologists highlight flaws in studies linking solar activity to earthquakes, small datasets, cherry-picked data, and random clustering. They argue that plate tectonics alone explains Kamchatka's quakes. Solar terrestrial physicists, however, point to new analyses and lab experiments showing electromagnetic fields can alter rock friction. Advanced monitoring systems and AI now sift through vast data, searching for subtle patterns. Disagreement is healthy. It pushes science forward. The real progress happens where skeptics and innovators meet. Kamchatka's ground has quieted, but the question remains: coincidence or connection? Science is a journey, not a set of settled facts. The consensus holds that tectonic forces rule, but history shows that bold questions lead to discovery. The Kamchatka quakes challenge us to look deeper. As technology advances, we gather more data. Perhaps one day we'll know if the sun truly shakes the Earth. Maybe the link is an illusion, or maybe our world is more interconnected than we imagine. Until then, we ponder the mystery, watching the skies and feeling the ground. The greatest questions are those we cannot yet answer.